Hello, everyone. Welcome. Hi, Saryab. How are you?
Hey, hi everyone. I'm doing very
How's
well. How are
everyone
you?
doing? Good. All right. So today we will be with Saryab, who is the lead smart contract engineer and tech team lead at Push Capital. As you already saw on the announcement, we will be talking about Ethereum and smart contracts. And Saryab is also adding a bit of Web3. So I will leave Saryab to present himself, give a brief introduction of what he does, and then we can all start with the lesson. For the chat questions, remember that we will be doing the lesson first, and then we can take a Q&A. Saryab, maybe if you agree, we could do the first Q&A for the first part, and then we do a final Q&A after you finish. So we have around 2 Q&As. So yes, any questions, just please post them in chat and Saryab will answer them. Again, welcome everyone. And I leave the floor to you, Saryab, and thank you for being here today.
Sure, my pleasure. I think, yeah, the procedure seems fine to me. We can, maybe I can stop in between and we can have a Q&A and then we can start again. Perfect. So I think I can just share my screen because most of what I have is in the screen. So yeah,
sure.
Give me a few minutes. Let me know if you guys can see my screen and hear me okay.
Yes, both are okay.
Perfect. Perfect. So I think I should begin, right?
Yes, go ahead.
Lovely. So hi everyone. Let's begin the session. So let's start with a brief introduction about me. I am Zaryab, as you might already know. So basically, what I do in the Web3 world is I write smart contracts. I perform security audits on the smart contracts, which basically means I not just write code, I also try to review contracts, try to find bugs in the contracts and protect the contracts as much as possible. I also create technical content around blockchain and smart contract. Mostly it's Solidity and security stuff. So in a nutshell, most of my life right now revolves around smart contracts. And that's what I'm going to talk about here as well. So let's before we begin, let's plan the journey a bit. So this is going to start with a brief introduction about Web3. So I was actually thinking about how to start this session, and I thought the best way to start is actually to start with Web3 and the term Web3 itself, because as soon as you enter the blockchain world, the first thing that you will hit is the entire ideology of Web3. And I'll talk why it's important to know what Web3 is before you dive into development or any sort of thing in Web3 world. First, we start the history, then we move towards the introduction of Ethereum and smart contracts, which is going to be the core material of this entire presentation. And then in the very last section, which is called the inception, which basically means how do you start in the Web3 world, which is not just for developers, but for everyone and everything possible. So this is going to be 3 stages of this entire presentation. The first stage is understanding the Web3 history. So yeah, let's begin. Cool. So as I already mentioned, the moment you start learning about blockchains, any protocol, smart contracts, anything, chances are you might hit the term Web3. And unfortunately enough, when you start learning about Web3, you will find that the entire world is really chaotic. There is no single narrative of what Web3 is right now. Because of all the attacks that we have been facing since the start of the Web3 world, from big tech companies till from governments, what happened was basically the entire Web3 world, we became very defensive. We tried to come up with different meanings of what Web3 means to us. Some, like most of us, just compare it with Google or Facebook. And that's what basically is. So we created memes, we created different narratives of what Web3 is. People wrote different articles. And it's so much so that right now, if you go to Wikipedia and you try to look for what Web3 is, chances are you will find this line which says the entire specific vision of Web3 is still very blurry, which means people, apart from a very small population of people, no one really understands what Web3 stands for. So this is why it's really important, at least for me, to start a presentation with a brief understanding of what Web3 is. funny enough, when I started my journey in Web3 a couple of years ago, I was facing the similar issue where there were different narratives of Web3, and I could not really understand what exactly it means. So the best way to learn about Web3, at least for me at that point of time, was to learn it from the person who actually coined the term Web3, and that was Gavin Wood, who actually co-founded Ethereum. So I came across a blog which was Why Web3 Matters. I have also pasted that blog in one sheet for all of you guys so that you can go through it. And in that blog, most of what I know about Web3 and my beliefs about Web3 comes from that particular article of Gavin Wood, which is what I'm going to share with you all today. Uh, so forget all the technical stuff for a moment. Forget blockchain, smart contracts, Ethereum, nothing else. I want you to take you all back to the history, 1215 year in the medieval England, and there was a king who was named King John. So the story starts, and King John, as you might know today, was one of the worst king that the world has ever seen. He would just abuse all his powers. He would impose high taxes on his citizens, and he would do everything that a king should not do, basically abusing his powers. What happened was gradually when the citizens understood that this king is really bad and he's using his power in a very wrong way, they decided to sit down with the king and forcibly make him agree that this is not right and things need to change. The entire barons and they all sat down, and one document was released, which was called the Magna Carta. This Magna Carta is really one of the really beautiful and imperative documents in the history of mankind, because for the first time in the history of mankind, someone noted down that nothing should be above law, which basically means even if you're a king or a government, no one should be able to abuse their powers, and no one is really above law. So all the discussions that were done in that discussion with the king, they were noted down in a summary. And basically this document, Magna Carta, this basically included a list of rules and regulations that was supposed to be imposed no matter who the king is or no matter who the government is, but everyone should follow these rules and regulations. So ideally, this document became the foundation of freedom for any individual against centralized authority control or governments, right? Now, why I'm taking you to the history is because the way Gavin Wood defines Web3 in his article is basically, he says that it's an executable Magna Carta, which means the same principles, the same values of rule being above all else. Now all of it is possible to be executed within computers, right? And that's what this is the level he sets for Web3.
Sorry, I'm
how
sorry
exactly?
to interrupt.
Yeah.
Could you put the slides on a slideshow, since we have
Sure.
it's easier for everyone to see it. Thank you so much.
Is this better now? Or let me put it this way. All right, give me 1 minute. I can just fix it. Can you guys see the screen now?
We can't.
Hello, is my voice audible?
Yes, but we cannot see the slides.
Okay.
The first time when you did slideshow, that was.
Can you see it now?
No.
Is it visible now?
Yes.
Okay.
Awesome.
Cool. I think I can keep it like this. That
yes,
works?
Perfect. Thank you.
Perfect. Sorry. So sorry for the interruption. So yeah, we understood what Web3 was, and we will dive into a bit deep into this entire executable Magna Carta part. But now let's understand the most important components of Web3. So no matter what narrative of Web3 you come across with in future, remember these three important components that we have in Web3 right now, which the first one is decentralization. So like we mentioned, no one should be above law, but when you put enormous powers in the hand of just few, chances are they will exploit it. the first component of Web3 that is really imperative to understand is the fact that it imposes decentralization, which is it wipes out any central authority control. Instead of one single authority, now there is a node and a group of people who manage a network and who manage the truth of that particular network, which is why we are able to wipe out complete central authority control. And we are able to build the trustless system, which brings us to the point number 2, which is trustless. Think about blockchain for a second. I mean, if you even know the brief history of blockchain and how it works, you might know that it's immutable. Anything that you put on the blockchain cannot be changed. Anything that you put on the blockchain is transparent, right? You can go at the blockchain and see anytime, any transactions, which basically allows us to build trustless systems, right? Which technically means in order to transact with each other, we don't really need to trust each other. And this is really important and an important component of Web3. And the third, which is the most important one, and my favorite, is ownership. So we humans have been users of the web and users of the internet since very long. But Web3 for the first time allows us to be owners of the internet. So how it does that is basically, in case you've heard of tokens in Web3, which technically means that any product that you use, for example, let's say Uniswap or Compound, or you might use in the future, what they do is they give you tokens of that particular product, right? Now, the moment you hold that token, you actually have a say in how the protocol should be. So let's say, for example, I work at Push Protocol and we have our own token called Push, and that majority of the token is owned by the community. So whenever, let's say I am the smart contract guy and I want to include a new feature, I cannot just go and develop any feature in the smart contract because Web3 is owned by community and owned by users. And users are the ones who have the tokens and who have the say in what the future of the protocol should look like. So whenever I want to create a new feature, I can just go and create a proposal that, hey, this is the feature ABC that I want to launch in the smart contract. Do you guys agree? And the community can then vote using those same tokens that they have in their wallets, which basically makes them really important actors who decide the future of the Push protocol, right? And this basically makes them not just the user of our product, but also the owner of the product, because now they have a say in which direction the protocol should move. So decentralization, trustless, and ownership, these three are the main components that Web3 provides us, right? Now let's dive into the technical stuff. This was just a brief introduction of what Web3 comes from, and just to clear out any chaotic narrative that you might have heard about Web3. Now let's understand about blockchains. So very simpler definition is an open distributed ledger that can record transaction between two parties, which is not just in an effective manner, but also it's also verifiable and permanent fashion. Now notice the ones that are highlighted here. The first one is open, right? Which means it is available for everyone to see. The second is distributed ledger. This is a database that is not controlled by one single entity, but it is distributed and across all the actors using the network, which is verifiable. Now, I mentioned that every record that you put on blockchain is basically transparent. Anyone can see it, so anyone can verify it. And which is why we say in blockchain world that do not trust, simply verify, right? And the most important one is in a permanent fashion. So any record that we store in the blockchain, it's immutable. It cannot really be changed. So it's basically like an append-only database where you add data, but you cannot remove it completely from there, which actually ensures that it can be trusted and no one really can tamper with the data, right? Now, this was just the layer one definition of what blockchains are. Blockchain has been a technology since very long, but the first time it was used very effectively was when Satoshi Nakamoto launched Bitcoin. For the first time in the history of mankind, he showed us how easy, effective, but important it was to transact with each other without the need of central authority control, right? And since then till now, if you look at the Web3 world, there has been enormous developments and use cases of blockchain so far. We're not, right, as of now, billions of dollars are logged in DeFi protocols. We see that there is enormous use case in healthcare sector, gaming, crowdfunding, P2P payments, and a lot more, right? What exactly led to this change? So Ethereum as a blockchain was the one that really raised the bar. And I discuss about why Ethereum is different with Bitcoin and in a few slides later, but let's understand Ethereum briefly for a second. So what Ethereum is basically a blockchain-based computer platform. I mean, the native currency is Ether, as you might already know. The incredible difference that we have between Bitcoin and Ethereum is the fact that Bitcoin is really just a ledger that holds your money and that allows you to do simple transactions from one person to other person, right? But Ethereum is a game changer because for the first time, it allowed developers to deploy their own apps on the blockchain, right? Which are not really controlled by anyone. You can deploy or take out your app anytime you want. And it uses basically the proof of stake mechanism. Now, this is what I'm talking about. So Ethereum for me is basically a way to lead more innovations. The reason is if you look at Bitcoin and the entire Bitcoin structure is basically your money, which is held in digital form without any central authority control. So you basically own your keys, you basically own your money. Bitcoin keeps a track of who spent how much, when your balance increase or decrease, and that's pretty much it. It's pretty static. But Ethereum, for the first time, it actually saw the vision and the power of blockchain that it is not simply for financial transactions, but it can be used beyond that thing, right? And the way Ethereum does that is basically it allows us to, basically Ethereum contains executable code. So you can write code that can be executed on Ethereum, which is something that's not possible in Bitcoin. It's pretty static. And because you can actually write your own programs and deploy it on Ethereum, it opens the doors enormously for a lot of developers to build on top of it, and which is what we will see as we go forward in the smart contract section. So Ethereum basically means the way it is designed, the way it allows developers to build a lot of applications. It's really great for innovations. But before we move on how this entire magic happens and what smart contracts are, it's important to understand this entire structure of decentralized thing that we're talking about. So in case you have noticed till now, we have been talking about decentralization, which technically means that we are not talking about a software which is centrally controlled, which has a central authority. The reason is the fact that when you have a centralized database, there is usually one owner or one manager who is capable of adding or removing data from the database, right? But now that we're talking about decentralization, how do we ensure that who will add data into the blockchain? Because I can't do it alone, because if I do that, if only me is allowed to add new data into the blockchain, then it becomes centralized because I am then the owner. I can remove or add any data I want. So it cannot happen like that. When there is a group of people who are basically supposed to manage the network, who is the owner or who actually adds the data? No one person. The answer is not a single person. The answer to that question is consensus, through consensus, which basically means the entire group agrees to a particular truth of which block should be added in the blockchain, and that's how we proceed. So consensus in general mean an agreement. When a group of people come to a particular agreement, that's called consensus. But in blockchain terms, it basically means an agreement that decides the addition or removal of a particular transaction in a block, which technically means that consensus system or consensus protocols allows a diverse group of nodes who can belong from any geographical location to agree on to certain truth about that blockchain, right? So far, there are two really famous ones and the really widely used ones, which is proof of work and proof of stake. And let's quickly dive into each one of them. So, all right, let's talk about proof of work consensus. This is how the Bitcoin network is basically managed right now. In this mechanism, we rely on the miners, which basically means that miners are supposed to solve extremely complex cryptographic puzzles, which basically means that the miner who actually solves the puzzle first ensures that they have done some particular work, and they are the first one to solve the puzzle, is allowed to add a new block into the blockchain. Now, the thing is, solving that particular puzzle is so difficult and is so power consumption process that even if someone tries to attack that particular network is really hard, because the entire investment that you might give for planning the attack might be lower than the result that you get from that attack, which is why it's really next to impossible to attack or to do a 51% attack on the Bitcoin network. Now, if you look at this very clearly, there are some really downsides of this protocol, which are clearly visible. The first one is this is highly energy consumption procedure. So if I want to be a miner on Bitcoin network, I really need big computers with extreme superpowers so that I can solve cryptographic puzzles faster and most importantly before anyone else does. Because there is a lot of miners competing for this, there is also a result which basically leads to slower speed. And by the way, like I mentioned, because I need a very strong system for this, it's really costly to be a miner in the Bitcoin network. An alternative to this is proof of stake, which basically means that now we don't really rely on proof of work. We don't really rely on extensive computation powers, but we rely on proof of stake. Now, Ethereum recently moved from work to stake. This technically means that now the person who is going to validate or add new block to the blockchain are not going to be decided on the basis of who solves a puzzle first. They are going to be decided on the basis of the stakers who stake their coins on the blockchain. So now proof of stake works in a way that if I want to be a staker, I have to stake a particular amount of coins onto the blockchain, which basically means they act as collateral. Why do I need to stake the coins? First of all, that basically means that I want to be a miner or validator of that network. Secondly, it's used for rewards or penalization. So if I'm a good actor, I'll basically earn rewards. But if I'm a bad actor who is trying to include malicious transactions into the network, I'll get slashed. Which slashed basically means the coins that I've staked will be lost or will be reduced in value than what I staked. This because now I don't compete with a lot of miners to be the first one. There is a lot of there is a lesser requirement of energy now, because now we are basically choosing stakers randomly, and there is no need for competing and solving cryptographic puzzles which are really hard. But again, proof of stake in itself, I think I should have written stake here, but yeah. So proof of stake also have some downsides, which technically means that since now we have a particular group of stakers, and by the way, the people who stake these coins are usually the number of coins that you're supposed to stake is usually very high. So not everyone can be a staker, which technically means only a handful of people can be stakers, and this is slightly less decentralization procedure than proof of work. And overall, it might affect the security as well. But this really reduces the energy consumption in running a particular network, right? So these two are the really good protocols that we have in consensus mechanism. But now we come to the most interesting part of this entire presentation, which starts with a question. So let's talk about blockchain technology, which actually exists for a second. So like we mentioned, like right now, if we look at the DeFi world, we are able to do enormously, incredibly amazing use cases. For example, we can do flash loans, we can do decentralized loans. We are using blockchain technology in the healthcare sector. We are using it in gaming for NFTs and stuff. But is blockchain technology alone capable of this wide range of use cases? Because if you look at blockchain technology, it's basically a static tech, which basically means you can add things to it, you cannot remove things from it. And that's basically it. So then the question remains, what actually allows us to do such complex use cases of blockchain? And the answer to that is smart contracts. No matter what use case you choose right now in blockchain, chances are there is going to be smart contract, which is why I say at the heart of blockchain lies smart contracts, because almost everything that you see right now in Web3 world, from ERC20 tokens to NFTs to flash loans, everything revolves around smart contracts, and everything is possible because of the smart contracts. So that brings us to the most interesting part of the presentation, which is what exactly are smart contracts. So starting from the history of smart contracts, it was invented by Nick Szabo, who was an American computer scientist. Quite opposite to what most of us might know. We might think that smart contract came into existence after Ethereum, but technically they were existing before that, since 1994. But it gained a lot of popularity after Ethereum started using smart contracts, because Ethereum was the first one who actually included a very interesting use case of smart contracts, which we discussed in a couple of slides earlier, which is Ethereum allows us to run executable codes, and that particular code is what we have as a smart contract. So if we have to define smart contracts in a very simpler terms, how would we do it? As the name suggests, it's basically contracts, which basically means agreement between two parties or more than two parties, But the trick here is that these are smart contracts, which technically means these are smart agreements which do not require any central authority to govern that the terms of the contract are met. The terms of the contract will be met because it's automated, it's self-executing. It does not require a human trigger to ensure that everything is working fine. Now, smart contracts are basically self-executing digital contracts. They execute, and this is very important, they execute only when particular conditions are met. Particular conditions that were coded in the smart contract, whenever they are met, only then a particular transaction happens. Just like blockchains, smart contract, because they're deployed on blockchains, they inherit from their feature, which is immutability. Once you deploy a particular code on the blockchain, you cannot really remove it or update it. I mean, there is a way to update it, which is called upgradable smart contracts, which will come to that later. But ideally, smart contracts are immutable, which is why we can trust them. So if I write a contract and that has been verified that this contract is completely fine, and once I deploy it on the blockchain, even though I am the writer of the contract, I cannot go and change the contract to do something malicious. And that's why people can trust the contract, because now they know that it's completely immutable for anyone to change it. And like I mentioned, smart contract, they are self-executing, which basically means that there is no need for any middleman for the execution of particular conditions. It is self-executing contracts, right? And because it's self-executing, it wipes out any central authority control in the transactions. Chances are, if you try to understand what smart contracts are, you might come across an analogy which is called the vending machine. And the reason it's compared with the vending machine is very obvious, and I'm going to do the same because this is the best way to understand smart contracts in a simple way. So I assume most of you might have used vending machines, and just think about it for a second of how it exactly works. So forget about smart contracts. You go to a vending machine and you want a Coke, and let's say you give $5 and then it gives you a Coke. Nothing more, nothing less, valid inputs, valid conditions, and valid output. If a Coke is supposed to be for $5, you will get it only for $5. If you give $4, it won't work, and you won't get a Coke, right? Smart contracts execute in a very similar fashion, which technically means there is a self-executing contract, there is self-executing program that has been made and deployed on the blockchain, and now it does not need any human intervention. You can just go interact with the contract, and it will only execute or give you certain outputs when the particular inputs and conditions are met. Now let's understand this from a smart contract perspective, right? So let's say there is a smart contract which allows a particular user, Bob, to withdraw 100 tokens every 7 days, right? For the next 3 months. So what are the conditions? That Bob can only withdraw 100 tokens out from the smart contract? What are the conditions that he can only withdraw those tokens at an interval of 7 days? Now, let's say Bob comes to the contract and he wants to withdraw 1,000 tokens after every 7 days. The contract execution will fail, and he will not really get any token in his address, right? The reason, because he provided a invalid input, which was 1,000 tokens. He was supposed to withdraw only 100 tokens. Now, let's say another scenario, he comes and he says, okay, I want to withdraw 100 tokens, but he wants to withdraw it before 7 days, let's say in the 3rd or 4th day, which technically means he did provide valid input, which was 100 token, but the condition in which it is being executed is wrong. He was supposed to withdraw those 100 tokens after 7 days, not after 4 days, which basically means the smart contract execution will fail again because valid inputs were made, but the conditions were invalid. So Bob can only withdraw 100 tokens when he wants to withdraw 100 tokens after an interval of 7 days. And if those both input and conditions are met, he will get the output, which is 100 tokens in his account, in his address. So this is how, in general, smart contracts execute, which technically means there is a very deterministic way of how they execute, because once you have written the code, it's going to execute exactly like that without the need of any human intervention who enforces that the contract should work like that. Now things get really interesting, because we're going to see a cycle of how smart contract development in general works. And I'm going to share my experiences as well of what you should keep in mind if you are developing one. So like we mentioned, right, smart contracts are basically immutable with the moment you deploy it on blockchain, which basically means that once you deploy it on the blockchain, you can't do anything else. Even if you find the bug, it's really hard to change after you deploy it on the blockchain. That basically means that you have enormous responsibility as a developer on your shoulders, that you ensure that the code that you're writing for the smart contracts is completely accurate. And you're not writing it invalid. You're not writing it in a bad way that might lead to further attacks in future. So there are two important things when you design the smart contracts. The first is defining the checkpoints, and the second is designing the game theory. Checkpoints basically means how exactly are functions supposed to execute when users are interacting with it. So let's say if there is a function in the contract which allows you to transfer ownership of the contract from one address to another address. That function is an external function, which technically means anyone can call it. But if anyone can call it, then chances are people might provide invalid input to that as well. So let's say if someone says, okay, this the owner of this contract should be a 0x address, which is a zero address, which basically is a null address. And once the contract ownership goes to the null address, no one can actually access the contract. So defining checkpoints means every function needs to include valid input validations, which technically means that even if the user or the actors who are interacting with the contract, they are providing an invalid input, the contract execution should not work. The contract execution should only work when there is a valid input provided to the contract. And the second is designing the game theory. Now, I have been saying that smart contracts are capable of executing on their own. They don't need a central authority control to manage them or to execute them, which basically means that everything that happens in the contract should be defined in the contract, and the contract should be able to manage the entire thing. So why this is important? Because we cannot really proceed the development of a contract with the perception that every actor who interact with the contract is going to be a good actor. Chances are there might be a bad actor as well, right? So a smart contract, when you design it, you need to ensure that the game theory is right. The game theory is basically means win-win situation for everyone. So if there is a good actor in the smart contract, they should be rewarded. But if there is a bad actor in the smart contract, they should be penalized, right? Okay, let's say we want to understand this from an example. So, all right, let's say the contract that I built for push protocol, there is this function which allows you to create a new channel, let's say, and any good actor can come and they can create a channel. But what is not allowed for you is to change your channel name again and again, right? So if I come on the push protocol and I create my own channel saying Zaryab first, and then I create the channel is deployed completely fine. But let's say if I'm a bad actor and I want to change the name of my channel from Zaryab to Uniswap, right? So that I can gain more traction because Uniswap is a popular protocol. If I try to do that, that basically means I am a bad actor, right? And the moment I try to change my name to a completely invalid name, the smart contract should be able to detect it and should be able to penalize me, which basically means that the stakes that I have in that contract should get slashed, right? That's the punishment of me being a bad actor. So if this is interesting because smart contracts are not only capable of documenting the rules of how it should be executed, but it's also capable of enforcing the rules. So it doesn't just say that good actors should be rewarded and bad actors should be penalized. It is actually penalizing me if I'm doing something bad. And that's the beauty of a smart contract, because it can execute on its own, it can reward me on its own, and it can penalize me on its own without the need for any central authority control. So these are the two things that you have to keep in mind when you write a contract. Now let's try to understand how exactly the development cycle of this contract looks like. So the very first thing that you have to keep in mind is when you develop a smart contract, no matter in what language, Solidity, Viper, anything, these are going to be immutable code. Once you write it, you will not be able to change it, which technically means that you need to be very sure of how to write these codes. And you can only be sure if you document the entire functionalities in plain English first. So you document the entire thing of how you want your contract to be executed. You document its intended behaviors. For example, if A happens, then B should be executed. If C happens, then D should be executed. So every flow of how the contract should execute, every edge case scenario that you might think that occur in the contract, every bad actor that might come to the contract, everything needs to be considered before you start even developing the contract. One bad practice of developing smart contracts is when you just open an IDE and you directly go to code without thinking of how the code should be, because once you deploy this code, you cannot change it. So documenting the entire theory of how your contract is supposed to behave is really imperative. And that's how you should start it first. So the very first step is to convert that entire document into code of your own choice of language. So let's say you are using Solidity, you start reading the document and then you convert the entire document into code. Once you have done that, then it's really important for you to test the contract. Why is it important? Again, the same reason. First of all, any language that you use, chances are it's fairly new right now. For example, Solidity is still in its 0.8, 0.9 version. Every time there are new bugs that come in the smart contract, and it might affect of how you expect your contracts to behave, right? So whatever contract you develop, it's really important for you to test not just the basic things, but every edge case corner, edge case scenario that might occur. One other reason is also the fact that you can only test your contract once, because once you deploy, then it's completely done. You cannot, even if you find any issues after deployment, you cannot really change it. But testing is not where you are supposed to end. Auditing is something that you also need to consider, and we will talk about what auditing in a smart contract and what the audit industry in general means. So after you have done testing, and there's a difference between testing a smart contract and auditing a smart contract. So let me give you a brief idea of what it is. If I'm a developer, I do write the code of the smart contract and then I test it. Testing basically means I am testing the intended behavior of the contract. If function ABC of my contract is supposed to behave and execute in a particular way, through my test cases, I will verify whether or not it's executing in the expected manner, right? That's test cases. But auditing, on the other hand, is more into the security side of the contract, which technically means that no matter what my contract is supposed to behave like, does it have any security bugs that might affect the entire funds that might be stored in the contract? Security audits are really important, and basically testing and auditing both needs to be done after you have ended the development of the code and before you are deploying the code on the blockchain, because it's really important to have a fresh set of eyes on your contract from as many people as possible, so that you can identify bugs, fix bugs, and make your contract pitch perfect before you even think of deploying it on the blockchain, right? So step one is to write the code. Step two is to test it, audit the smart contract, and step three is to actually go and deploy it on the blockchain. Once you deploy it on the blockchain, that's when your contract states are initialized and it's all set for people to interact with. And finally, the contract starts executing. So whenever someone wants to interact with the contract, now they can interact with your contract. Every function that allows you to read from the contract, they are basically can be done in a gasless manner. But once someone tries to interact with your contract, they will have to pay gas. I mean, talking about gas, one important thing that we might have to notice is when you develop the contract, you have to make sure that people who are using it, because anything that you do on chain basically will require gas fees, right? You have to pay some sort of fees to the blockchain to interact with the on-chain data. So when, let's say there is a function ABC that allows me to stake some coin on some of my coins on the contract, when I call that function, it basically means I'm interacting with the on-chain data. I'm interacting with things that are deployed on chain, which basically means I have to pay a certain amount of gas. Now, if you are a developer of a contract, your job is not just to ensure the behavior of the contract and the security, but your job is to also ensure that the gas optimization of the contract is made right, which basically means you have written your contract in a way that it uses very less gas from the users, because if you write really bad code, chances are the users of your contract will have to pay a lot more gas than they should. So gas optimization is also one of the things that you have to consider when you develop contracts. So yeah, finally, this is the entire execution cycle of how the smart contracts look like, development look like, right? So again, if we recap this entire process, now that we know what smart contracts are and how they're developed, if we have to recap the entire thing, first point is it doesn't just define the rules, it also enforces the rules, right? It doesn't just say that good actors need to be rewarded and bad actors to be penalized. It actually goes ahead and does that. Second thing is speed. So take any example for a second. Let's say payments or even taking a loan, in traditional world, it's really difficult to take a loan because it's an entire lengthy process of how you do it. It's heavy on your pockets, and there are a lot of middlemen that are involved in the entire procedure. But in DeFi, you can actually take a loan within seconds, right? So smart contracts, because they've eliminated central authority control, because they have eliminated human chances of human error, because they've eliminated middlemen, now it's incredibly easy for you to interact with the smart contracts and do any financial transaction that you might have done with a long time and a long costly thing in the traditional world. Third thing is reliability, which basically is what we discussed. Smart contract code cannot be changed even from the one who develops it. Even if I'm the developer, I cannot go and change it, which technically means that people can actually trust this code and they can rely on it because they know that everything that they see on the contract, they can verify it. Every transaction is verifiable. They can see who is calling the contract and what they're doing, and they can actually see that the code is not being changed and cannot be changed. Fourth point is cost effective, and the fifth point is deterministic, which technically is what we discussed already, which basically means that the code that you have written and you have deployed it, it cannot be changed. And we exactly know for a particular flow how the smart contract is going to work. And it will always work in the same fashion because there are no humans involved who might alter the way smart contracts work. And the most important part of it all is the elimination of third-party interference. Because smart contracts are capable of doing almost everything on their own, they don't really need anyone to govern them, right? But here is the interesting part. So is it really all sunshine and rainbows? And basically, I think I should stop right now and maybe give some time for questions in case we have some. So yeah. All right, so should I just go ahead and read the questions and answer them?
Sure, yes. Just please make sure that you read them out loud so they know
Sure.
which one you are responding to.
Sure, people go ahead and drop your questions. I think most of them already have, so yes. I'm gonna pick some questions right now. Will the slides, yes, the slides will be available afterwards.
So yeah, maybe we start from the top and go all the way down.
Yes. There is no question. Okay, so if I want to be a Web3 developer, so HTML and CSS need to learn. Okay, I will come to this specific part at the end of my slides where I talk about how any one of you, no matter if you're a developer or you are a writer or designer who can enter the Web3 world and how they can enter. So I'll talk about this, but ideally HTML and CSS are not really requirement to be a Web3 developer. They are requirement for being able to understand what works on the web. So while it's not really a compulsion, but I think it's a good starting point to know the basics of HTML, CSS in case you think of being a web designer. And let's say if you're designing a dApp, you can write the smart contract code with just Solidity, but you cannot really design a web if you don't know HTML and CSS. So if you plan to be completely in the smart contract zone, you might never need HTML and CSS, but if you want to be a full stack developer, then I think you need to learn HTML and CSS as well. Okay, coming down. What kind of language is like Java, C++, conditional, etc. I'm not sure this question, what exactly it means, but I think he's asking what sort of language is he supposed to learn for learning Web3. So I would say if you are a complete beginner into programming, start with JavaScript. The reason I say that is because Solidity is very much similar in the way it looks and in the way it can be coded to JavaScript. So if you are completely new to programming, chances are if you start with JavaScript, you might have a good hand in Web3 in general. So, okay, let's go to the next question. What do you think about the fear of centralization around POS? Do you think ETH 2.0 staking protocols contain danger against decentralization of the ETH, like Lido? In fact, yes, I do think it's a danger to decentralization because, like I mentioned, and that's the only part of proof of stake, by the way. I think this question is asked by Ibrahim. So, Ibrahim, this is the only part of proof of stake that actually concerns me is the fact that not everyone can be a staker and you have to stake 32 ETH, like Angie mentioned, to become a staker. And there is only a handful of people who can do that. And basically that does lead to a threat in centralization, a decentralization fashion in what we did in proof of work. So yeah, that's something that probably will be fixed as we have more and more stakers and they are chosen in more random way. And we ensure that it's not done in a very centralized fashion. But as of now, yeah, that's some sort of thread that we have. Cool. So another question by Nargiza is, can you tell me more about your background, role, and how did you enter DeFi specific role? Cool. So my background was I started as a backend developer. I used to mostly code in Python. And then I realized that the Python community is not that strong. I mean, back in 2017, it was not that strong in Web3. So Web3 is more inclined towards JavaScript, and all the libraries were JavaScript. So I had to learn JavaScript. And then basically my background is the fact that I came from a backend development perspective, and then I switched to smart contract development. But ideally, I was also interested in the smart contract security. So the way I entered the DeFi space was completely as a smart contract person who writes code in smart contract Solidity and who audits the contract written in EVM, written for EVM chains and Solidity. So that's my background: a smart contract developer and an auditor. Can you repeat the definition of checkpoints? Checkpoints basically means your way of ensuring that people who are interacting with the contract are interacting it in the right manner. They are not passing arguments that are invalid. They're not passing arguments that might lead to unexpected behavior in the contract. That's what checkpoints basically means. Do you test the contract? And this question is asked by Nargiza again. So do you test the contracts on, okay, I lost it. Yeah, do you test the contract on testnets? And what are the actual steps of auditing? The actual step of auditing, I'm just gonna present in my next few slides. I don't really test my contracts on testnet specifically because you will get a lot of tools like Hardhat, Foundry, or Truffle, where you can actually write your test cases and then test it directly by running a script. For beginners, it might be a bit tricky, but once you start learning, I would recommend learn Hardhat or Foundry as of now to learn how to test smart contracts. That would really help you. And you don't actually have to go and deploy a contract on testnet and then try to call each function. That's a really lengthy procedure. That's not how things are done. The way things are done is basically you use a particular development tool and then you basically fork the mainnet and then you write the test cases the way you want the contracts to work. Okay, moving forward to the next question. Can you provide a clear and effective roadmap to become a successful smart contract developer? Yes, I will in the last slides. Just stay with me. How are smart contracts compiled to machine code using the EVM, which basically converts the entire smart contract, which is a high-level language, to a low-level language, which is basically known as the assembly code or the opcodes. Basically, that's how it is converted. Will the slides be available afterwards? Yes, they will be. How do bad actors take advantage of bad code in smart contracts? I think I'll cover this one in the next few slides, but ideally, if you basically smart contracts, if you look at it, they are not just any code. They are codes that are capable of storing money. And wherever there is money, chances are there are bad actors who will try to take that money. Bad actors can do a lot of things bad with the smart contracts. And also one of the reasons they can do bad things with smart contract is because smart contracts are out in open. So if I write a code on a blockchain and I deploy it, anyone can go and see that code. So it becomes very transparent for you to see the code, for you to analyze the code, and for you to find issues that you might be able to exploit. How can bad actors take advantage? They can do anything. They can steal the money. They can change the ownership of the contract and then later do something really fishy. They can do a DOS attack on the smart contract, which basically will stop it from executing any further, and so on and so forth. Is it possible to cheat a smart contract in some way, like where it seems that certain conditions are fulfilled by in, and in reality they are not? Matthew, that's a very good question because it is possible. If you have seen the bridge attacks that are happening recently, that's how they are. So you make it seem like, I mean, that's again bad code and bad implementation. So which is why auditing is important, which helps you figure out how can you remove those bad codes from your contract before you deploy on the testnet or mainnet. But yeah, it is possible for someone to find loopholes. It is possible for someone to make it look like they're performing it the right way, but actually they are doing something really bad. Okay, Sarmad asks, smart contracts can be override? I think it's a question. So yeah, they can be, which is what we call as upgradable contracts, which technically means even after you deploy the code on the blockchain, there is a way for you to upgrade the contracts, but that's a very tedious way and you can still do it. But that comes with a particular set of requirements of how you should do it. So you should not just do it with a random EOA, because that would make the contract really unreliable. If I deploy a contract and I go and upgrade it anytime I want, people won't really able to interact with it and won't really able to trust it. So yeah, upgradable contracts need to be upgraded in a very secure manner. And then I come to the next question. Could you please explain the deployment of a smart contract and the execution part again? Okay, sure. I can do that if I get time in the class. If I deploy a smart contract for a project and during its scaling, I need to change a rule, should I write a completely new contract? Yes. So if you are writing a contract which is not upgradable, which basically means you are writing a one-time contract, you deploy it, then you can't really add any new feature in it because now it's done. But if you think that your contract might require new features again and again, time and again, and you might want to launch new version of contracts, then upgradable contracts is the way to go, Andre. And then the next question is Python a valid programming language to write smart contracts? I know Viper is a language that is very Pythonic language, which basically means if you are a Python guy, you might like Viper as a smart contract language, but using just Python and deploying it on blockchain, I don't think so. Yeah. Cool. Let's move to the next question, which are really short ones and I can cover. What are some tricks or best practices to reduce the costs when writing a smart contract? Cool. So that's what we call gas optimization. And there are quite a few tricks actually of how you can do it. One quick thing that I can do is I can share a list right now, which basically is a collection of all the different tricks of how to consume and how to optimize gas in your contract. So I'm just pasting the link here and you guys can take a look. I'll also add this link in the resource drive that I have.
Sorry,
cool. I think maybe we can start with the presentation and then go back to the questions again. Yeah, I think you're saying something.
Yes. Make sure that you post the links to everyone, not just host and panelists on the chat.
Oh, sorry, I didn't know that. So here you go, guys. This is the link for everyone.
Thank you.
Maybe I can do one or two questions more because there are a lot of questions today. So how a smart contract can be deployed on the blockchain? Smart contracts can be deployed using different tools. First, the very easy way is using Remix, which is an online IDE. If you don't have the link, I can drop the link here. This is the most easiest way of deploying contracts, but ideally, I recommend you use development frameworks, which is Truffle or Hardhat, and that's how you deploy contracts using deployment scripts. Cool. Aziz asked a very interesting question, which is there some risk models and risk measures related to smart contract like financial risk management, which is related to foreign derivatives and other contracts? So the sad part is we have not yet come with the official procedure of risk management of how contracts should be designed, that they are not really including any bugs. There is no very, very official list, but there are some firms, security firms, which are trying really hard to create the right kind of content to make people aware, make smart contract developers aware that how they should develop contracts and how to minimize the number of bugs that are there in the contracts. So some of those firms are Consensus, Open Zeppelin, Trail of Bits. You can go and check them out whenever you get time. So they really provide right content for you to write smart contracts that are really safe. Cool. Angie asked, do you suggest us to start with vanilla HTML plus Web3 plus Solidity, or is it better using frameworks? What frameworks do you think are best? Cool. If I have to, and again, I'll discuss it in the last section since there are a lot of questions about this, but I would suggest the right tech stack for starting learning Web3 development is JavaScript, Solidity, which was smart contracts, and then you learn Web3.js or Ethers.js, which basically allows you to connect the smart contract with your front end of the dApp. And then if you want to be a front-end developer as well, you have to learn React or any other front-end tool that is important. But if you are not really into front-end development, basically JavaScript, Web3.js, and Solidity will do just fine for you for writing smart contracts and interacting them on the front end.